Hi there everybody. I'm making this video to help you with the data table in assignment 2 for CrystalMaker. So at the beginning of the assignment you chose a bunch of minerals to represent the various crystal systems, and so what you'll do on this data table, first of all, is fill in the mineral names that you chose. So I'll only be doing one of these just as a demonstration. I'll be doing a mineral in the triclinic crystal system called ulexite. Great. And what we're going to be doing here is we're going to be measuring the unit cell edge lengths. The A edge length, the B edge length, and the C edge length. And then we're also going to be measuring the angle between those edges. The alpha angle, the beta angle, the gamma angle. And what those angles are the angles between C and B, if it's the alpha. Beta is the angle between A and C, and gamma is the angle between A and B. So alpha is the angle between the C edge and the B edge. So where those two meet, you take the angle measurement between them, and that's your alpha angle. So we will do each one of those for ulexite in this video. So I have ulexite loaded. It's, like I said, a triclinic mineral. It's hanging out right here. So let's have a look at our unit cell. We can just sort of drag around. You can see the orange outline of my unit cell, the dashed line. Notice there's two of them. So I'm going to change that. So I'm going to go to the inspector menu in the top right. I'm going to go to this tab, which is the model inspector. Under unit cell, if this drop-down menu is not open for you, just click that arrow. I'm going to untick multiple unit cells, and I am going to turn on labels. And so you might have seen some labels pop up, but a little difficult to see with all the atoms in the way, so let's turn everything off. Great. Okay, we can get rid of the inspector for now. Actually, before we move on, I'm going to change my background. And then, because it's a little hard to see, I'm going to make this black and a solid line. Okay, that should be fine. Turn off the inspector. And so let's look at the origin, A, B, and C. Notice how that's the same as these axial vectors down here in the bottom left. It's the origin, X is to the right, because X is A. Y is pointing down, so is B. Z is kind of pointing over to the left, same as C, right? All right, so this is our unit cell, and the first thing we want to do, let's go back to our assignment, is we want to measure the length of the A edge, okay? So I can see the A edge here, but I want to make sure that I'm very precise. I want to make sure that I'm seeing the whole A edge, that I'm not like obscuring it in some way. So let's go to the Orient tab, and we want to look down any direction that is not A, right? Because if we click this, then we're looking straight down the A axis, and so we can't see it. We can't measure its length. On our screen, it's essentially a point in space, and you can't measure the length of a point. So we're going to go to Orient. Let's look down the B. Why not? Either B or C, as long as we can see this distance here, which is the origin to the A. Okay? And what we're going to do next, let's just sort of reorient, reposition, so we can see, get it all zoomed in. And then we're going to use one of these tools down here that we haven't used yet. Right now it's defaulted to the bond distance tool. So we're going to click the little drop-down arrow that's next to the bond distance tool. And that should pop up this menu. We're going to select this tool here, the screen distance tool, or you can just press the letter R. So what this does is you can click in one spot, drag, click in another, and now we've measured a distance. Okay, simple enough. And it's in angstroms, if you're curious. That's the A with a little circle on it. It's called angstroms. So we're going to click on the origin. We're going to drag, drag, drag. We're going to get over to the A. Click. There's our distance, 8.521. And so let's bring the assignment back. The A distance is 8.521 angstroms. All right. Easy enough. Now looking at the axial vectors, I notice that I can see the z-axis, or the c-axis, going up and down. So let's just go over and have a look at it. There's the C, running up and down. Click our distance tool again. Click on the origin. Drag, drag, drag. Click. 6.667 angstroms. Remember, that was the C length, not the B, so we're skipping over that. 6.667 angstroms. And lastly, we need to do the B. But again, we can't do the B because it's going right into the screen. We can't take the length of a point, so we need to reorient. Let's look down the A. Let's move so that we can see the B. There it is. Running off to the left here. Go to the distance tool, click at the origin, click at B, 12.441. So the B length is 12.441. Okay? Now we want to do the angle between the edges. So remember, alpha is the angle between C and B, beta between A and C, gamma between A and B. So if we're doing the alpha first, we need to be able to look at C and B coming together at a corner. Okay? So let's do that. So can we do that here? Just looking at the axial vectors, I say yes, I can. B is coming in on the left, C is going up and down. So remember, C is here, B is here, here's the origin, this is the angle we want to measure. So let's zoom in, get a nice look at it. Okay? And just like there's the screen distance tool, there's also the screen angle tool, but the default is the bond angle tool. We're not using that right now. So we are going to click on the little drop down, click the angle tool, or press the letter N. And then this requires 3 clicks. We're going to click on the B axis. We're going to go over to the origin, click again. Now we've made a corner, and go up to C and click again. You can see our angle is 94.369. Let's go back to our data table. 94.369. Okay, there's our angle. Next is the beta. Remind yourself, beta is between A and C. Okay, so you need to see where A and C make a corner. What that means is we don't want to see B. So let's look down the B. Let's scale and center. So we can see C is coming down, A is running off to the side, which is what we want. We need the angle between A and C. So let's put the origin in the middle of our screen. Zoom, zoom, zoom. We want this angle. Click on our angle tool again. Click, click, and click. 108.389. So let's go back to our assignment. 108.389. All right, that's our beta angle. Last is our gamma angle. Gamma is the angle between A and B. So where A and B make a corner. So that means we don't want to see C. Let's look down C. Scale and center. A is running over here. B is running up and down. So there's our origin that we want to measure. Zoom, zoom, zoom. Okay. Angle tool. 3 clicks. 1, 2, and 3. 106.152. So we go back to our assignment. 106 point, what was it? It was 152. Great. All right. So we have got all the information we need. We have it all. And let's just think through the logic real fast. So if we have our information here, let me pull up another shot from your book, which is the crystal systems. So notice the triclinic crystal system, which I said we were in, but let's prove it. If we're in the triclinic crystal system, the A length should not equal the B, and neither one should equal the C. And the same thing with the angles. The alpha angle should not equal the beta, and neither should equal the gamma. Okay? So let's see if that's the case. A is 8.5, B is 12.4, C is 6.7, rounding. Okay? So none of those are equal. 8 doesn't equal 12, doesn't equal 6. Let's check our angles. 94, 108, 106. 94 doesn't equal 108, doesn't equal 106. None of them are equal. Okay? So we have proven to ourselves that yes, indeed, we are in the triclinic crystal system. Ulexite is a triclinic mineral. Okay? So you will do this same exercise for all of the different crystal systems, and hope this was helpful. I'll see you in the next one.